So now we will calculate the load for the waste slab as well as the steps as well as the landing. So let's start. So first one, the first part that we need to calculate, that is the dead load of the waste slab. So dead load of the waste slab, that means which portion, look over here, if we consider a single step, suppose consider this is the single step. So below the step we have a slab, right? So this particular portion is the waste slab. So we need to determine the dead load of the waste slab. So for determination of this waste slab, we need to know the following dimensions. First one is this one is the depth, right, and the d value is 250. So this one is 250. Now what other details that we already know? We know this particular distance, that means the tread value. What is the value of the tread that we considered previously? That is 300. So this one is 300 and the riser value, this portion is 150, right? So if you know this value, if you consider this as a triangle, so this is 300 and this is 150. So what will be the value of this? This is nothing but root over of 300 square plus 150 square. So the value that we get after calculation, it will be 335, near about 335 mm. Okay. So we got this length, that is 335, and we know the depth, that is 250. So the dead load of the waste slab will be 0.335, that is in meter, that means this particular length, into the depth of the waste slab, that is 0.250, into the length of the single flight, that means this particular one, that is 1.35. That means the length of the each flight is up to this 1.35, right, for a single flight. So we are considering for the single flight, that is the length of that single flight is 1.35. okay. So 1.35 into the unit weight of RCC, that you already know, that is 25 kilonewton per meter cube. Now this particular dead load is for 0.3 horizontal distance, 0.3 meter horizontal distance. Look here, if you can see, this is the horizontal distance. For this particular distance, this is a very important thing. In the books you don't find this thing. Look, this particular dead load is for this 0.3 meter horizontal distance, because look here, if you consider over, this is the waste slab, okay. If you consider this is the waste slab, so for this horizontal distance up to this portion, the dead load we have find, but we need to determine whatever the value over here, that is in per meter basis, right? Then we will multiply with the total length. So that is why we need to if we use the unitary method, that means when the horizontal distance is 0.3 meter, then the dead load is this one. Let me consider this as x. Now if the horizontal distance is 1 meter, the value will be x by 0.3. So that is why to determine in per meter basis, whatever the value we get over here, we need to divide that with 0.3. Okay, so then only whatever the value we get, that is in per meter. So after calculation of this, you will get the value, that is 9.42 kilonewton per meter. Then only you can write here per meter. Okay, I hope you understand this particular concept. Now in the same thing we need to do for determination of the dead load of the steps also. Okay, so let us determine the dead load of the steps. Dead load of the step. So dead load of the step means this particular portion, right? So what is the area of this triangular portion? That will be half into the base into the height, you can say 0.3 into 0.15. This is the area. Now same thing, the you need to multiply with the length of the single flight, that means this particular value, that means 1.35, right? So 1.35 into the unit weight of RCC, and same thing it is also for the horizontal distance 0.3 meter. So we need to divide this with 0.3 and we will get the answer, that means the value which is in per meter basis. Okay, so you calculate this, it will be near about 2.53 kilonewton per meter. Okay, now any other load is not given here, so we will consider the floor finish. That means if you provide the tiles and that kind of thing over there, so 1 kilonewton per meter, and the last one for the live load we consider over here 3 kilonewton per meter. Okay, and look, for the waste slab we have determined the load, the dead load for the waste slab we have determined, the dead load for the steps we have determined, the floor finish as well as the live load we have determined. But yeah, the remaining portion is the dead load of the landing slab. The remaining portion is the dead load for the landing slab, that means in these two portions. So in these two portions we need to determine the dead load. So what will be the value of the dead load? That is very simple. We know the depth of the slab, that means this particular depth, that is same as this, that means 250, and we know the total length here, that means the length of the waste slab, so that is 1.35. so 1.35 into the depth of the waste slab. Okay, and then you need to multiply with the unit weight of RCC, and then you will get, that is in per meter. So dead load of the waste slab will be 0.250, that means this particular depth into the length of the landing. So the length of the landing over here, that is 1.35, so 1.35 into the unit weight of RCC, that is 25. So in this way you can determine, so the value that we get 8.4375 kilonewton per meter. Kilonewton per meter. So now we have determined all the loads for our staircase. So let's summarize this. So the dead load of the waste slab, let's remove all this. So these are the summary of all the loads that we have determined. Now what we need to do is we need to make the we need to determine the total load which is acting on the landing slab, that means here in this portion, and the total load which is acting on the waste slab, that means in this particular portion where the steps is there. Okay, so if we make a diagram like this, so up to this portion we have certain loads. Now in the waste slab we have some loads like this, and then also in the landing slab we have something load like this. Okay, so here there are two supports because our supports are in the end. So this length we already know, this particular length we already know, and this particular length also know. So this is 3.3, this is 1.35, and this is also 1.35. okay, so we need to determine the load which is coming over here. Definitely these two are same because the dimensions are same, and we need to determine the load which is coming on the waste slab. So in the waste slab, first determining the load in the waste slab. Okay, so in the waste slab this particular load will come, that means the dead load of the waste slab, then the dead load of the steps, the floor finish, and the live load. Except this landing slab, all over the load we need to add in the to determine the total load in the waste slab. Okay, so that will be 1 plus 2 plus 3 plus 4, and the dead load for to determine the load which is coming on the landing slab, that will be this one, dead load of the landing slab, live load, the floor finish, and nothing else, because the dead load of the steps and waste slab is only for the waste slab. Okay, yes, so landing slab if we determine, that will be 3 plus 4 plus 5. So the value we get, that means the total load which we get after determination of the landing slab, that is Now this will be the value. We will multiply with the partial safety factor, that is 1.5, to make it the factor load, and directly we get the factor load. The value is 18.65 kilonewton per meter. Okay, this is the factor load for the landing slab, and the factor load for the waste slab, if you multiply it 1.5, so the value that we get, that is 24 kilonewton per meter. 24 kilonewton per meter. So here it will be 24. So here it will be 24 kilonewton per meter, and here it is 18.65 kilonewton per meter, and here it will be also 18.65 kilonewton per meter. Okay, so now we will go into the next step. So now we will determine the shear force, the value of the shear force. So now we will determine the value of the shear force. Okay, so what will be the value of the shear force? The maximum shear force at, if you consider at the landing slab, to determine the maximum shear force, so we have our support in these two end points, right? So if you consider the reaction force here RA, and here it is RB, so what will be the value of RA and RB? So as this is a symmetrical, you can see there is a symmetrical load, and the structure is also symmetrical, so we can write that RA equals to RB. Also we can write that RA plus RB equals to 1.35 into 2, because it is in both sides, and the load is 18.65 plus 24 into 3.3, because 24 is load is coming up to 3.3 span. So after, if you solve this equation, you will get RA equals to RB, that is 64.77 kilonewton. Okay, so the maximum, if you consider the shear force as, so maximum shear force, if you consider it as VU, so the maximum VU at the landing slab will be this particular value, that is 64.77, and maximum VU for the waste slab, that will be 64.77 minus 18.65 into 1.35, 18.65 into 1.35. So the value that we get, that is 39.6 kilonewton. Okay, so these are the values of VU, that means the shear force that we get. Now you need to determine the moment. the maximum moment. So then only you can determine, or you can check the the depth we consider, that means 250, whether it is correct or not. So for to determine that, we need to determine the moment first, right? So you already know how to determine the bending moment diagram, shear force diagram, that you have learned in strength of material classes, right? So same thing we need to do over here also. So let's remove this. So if we consider, so if we need to make the equation for this distance, which is at x distance from the RA, that means the A support, consider this one is as x, okay. So here I need to determine the moment, okay. So if we write like this, mx, where x is equal to 0 to 1.35, that means this the line lies between the 0 to 1.35 ranges, right? So what will be the equation? That will be RA into x, minus, look, you can say 18.65 into this distance, that means from here to here, that is 18.65 into x by 2, because the weight of this load will be passing to the CG point, and which is at x by 2 distance, right? So here you can write 18.65 into x, this is the total load, and the CG distance is from this line is x by 2, right? Here it is x, so half is x by 2, so into x by 2. So this is the equation for to determine the moment, from 0 to 1.35 distance, okay. So if you need to determine the moment at this particular point, so you will put the value of x over 1.35, and then you will get the moment over here. So if you imagine the moment diagram, the bending moment diagram should be like this. Here at this point it is 1.35, it is 1.35, so it will be something like this. Right, now in this particular point it will be, we will get the maximum moment, and if you put the x value 1.35, you will get the moment at this point, these 2 points, and if you put the value of x, which is 3 meter, because you can see from here to center of the point it is 3 meter, because the total length is 6 meter. So if you put here 3 meter, you will get the maximum moment. So we are interested with this particular moment, because we need to design the staircase with the maximum moment, right? But also we will determine this moment also. So this is the equation for the x equals to 0 to 1.35. Now we will determine the mx equation for up to this particular distance, that means x. So now we will consider the x distance, which is at a range of between the 1.35 to 4.65, because 1.35 plus 3.3 is up to here is 4.65. So now we will write the equation of mx, which where x equals to 1.35 to 4.65. So what will be the equation? So same RA into x is there, RA into x minus, so RA into x minus 18.65 is the load which is acting from this point to this point. So what will be the value of the total load? 18.65 into 1.35, this is the total load. Now load into the perpendicular distance, so we are considering this particular line, right? So what will be the perpendicular distance? So from here to the CG point of the load, the CG point of the load is there. So we know this particular what will be the value of this, the line? So that will be simple x minus 1.35 by 2, because up to this portion it is 1.35 by 2, right? So x minus 1.35 by 2. So force into the perpendicular distance, the moment. Now this load we have considered, now we are interested with this load. So 24 minus, because this is the downward, so that is why it is negative sign I am giving, and RA is upward, that is why it is positive. Okay, so 24 and where it is acting from here to here, right, up to this portion. So 24 into x minus 1.35, so then only we can get this length. So x minus 1.35, keeping it in brackets, and the load where it is acting, that means it is the CG point, from the CG distance, that means the center point over here and this particular distance. So that will be x minus 1.35 by 2, because x minus 1.35 is this total length here, and x minus 1.35 by 2, so we can write here square and by 2. So this is the equation for where the x value ranges about 1.35 to 4.65. So if you need to determine the mx value, that means the moment value at this point, so you need to put the value of x over here, that is 3 meter, in this equation. And if you need to determine the moment at this point, so you need to put the value of x, which is 1.35. Now you can put this value over on this equation as well as this equation also, because 1.35 is common for both of these two equations, and the value will be same for both of the equation. Okay, so the moment here that I get, that is 70.44 kilonewton meter. So if you put the value of x over here, that is 1.35, or over here, so the value you get, that means moment at x equals to 1.35, that is 70.44 kilonewton meter. Okay, and mx at x equals to 3 meter, you will get 103.10 kilonewton meter. So in these two point, the moment value is 70.44, and here it is 103.10 kilonewton meter. Look, this is the exact process that how you can determine the moment, okay, the maximum moment. Now as per code IS 456/2000, you can also determine the approximate value of this moment by using the formula W L square by 10. Okay, so you use the value of W, that is 18.65, to determine the moment at the landing slab, and you also use the value 24 kilonewton per meter, here you can see, to determine the moment at the waist slab. Okay, so you can also use this formula, that is W L square by 10. But yeah, if you need to determine the moment accurately or design accurately, so you need to determine the moment in the following way. Okay, that will give you the exact value. Okay.